All right, let's talk about one of the originals from AWS, a real powerhouse in modern cloud architecture, Amazon Simple Queue Service, or as you'll always hear it, SQS. Now, this isn't some flashy new service. It's a foundational tool. Think of it like a shock absorber for your application, a buffer that stops one little failure from taking down the entire system. We're going to break down how this simple but brilliant idea powers some of the most resilient applications out there.
So, here's what we've got on tap. We'll start with the problem that SQS was basically born to solve, this tightly coupled issue. Then we'll get into the weeds of how SQS actually works, how a message makes its journey, we'll compare the two big flavors, standard and FIFO queues, and finally, we'll check out some real-world examples and see where SQS fits in the bigger picture with other tools.
Okay, so let's paint a picture. You've got two different parts of your application, right? Maybe it's a service that takes an order and another service that handles the shipping. Now, the simplest way to connect them is just to have one call the other directly. But that direct line, it's hiding a pretty big danger.
And this, right here, is what we mean by tightly coupled. Service A makes a direct synchronous call to Service B. What happens if Service B is down for maintenance or just overwhelmed with traffic? Well, the chain breaks. The request from Service A just fails. The whole process stops dead in its tracks. It's a single point of failure that makes your whole system incredibly brittle.
This is exactly where SQS steps in to save the day. It's a simple, elegant solution. It puts a middleman, a queue, right between your services. And that one change completely flips the script on how they communicate.
So what is SQS officially? AWS calls it a fully managed message queuing service. Now, the two most important words there are fully managed. What that really means is you don't have to worry about servers, patching, or scaling. It's all handled for you. You just create a queue and you start sending messages. It's built from the ground up to let you decouple and scale out your apps.
So by putting SQS in the middle, your services don't even have to know about each other's existence. They just talk to the queue. This is huge for resilience. If your consumer service goes down, no problem. The messages just pile up safely in the queue, waiting for it to come back online. This also gives you amazing control over something called back pressure. Your consumer can pull messages as fast or as slow as it can handle, so it never gets overwhelmed.
Okay, so how does this all work under the hood? It sounds simple, but there's a really clever mechanism at play. Let's follow one single message on its journey through an SQS queue.
You've got two main players in this little drama. You have the producer. That's any part of your application that sends a message to the queue. And then you have the consumer. That's the worker that's constantly checking the queue, asking, hey, got anything for me? And pulling messages out to process them.
So let's trace the journey. Step 1, a producer sends a message, it lands in the queue, and it just waits. Then a consumer pulls the queue and gets that message. And this, right here, is where the magic happens. The second that message is picked up, a secret timer starts ticking. This timer is called the visibility timeout. And honestly, it's the heart of the whole system. For that period of time, the message is effectively invisible to any other consumer that's pulling the queue. This is so important. It prevents two different workers from grabbing the same job and doing the same work twice. If the consumer finishes its task successfully, it tells the queue, hey, I'm done, and the message is deleted for good. But what if the consumer crashes, or the process takes too long? If that timeout expires before the message is deleted, it just pops right back into the queue, visible again, ready for another consumer to give it a shot. That's the secret sauce to SQS's resilience.
And just to give you a sense of the scale we're talking about, a standard SQS queue can have roughly 120,000 in-flight messages at any one time. That's 120,000 messages that are currently invisible because they're being processed. That shows you the kind of massive parallel processing SQS is built for.
Now, it's not a one-size-fits-all situation. SQS actually offers two different types of queues, and picking the right one is super important because it really depends on what your application absolutely needs to do.
So the default queue is called a standard queue, but sometimes you need much stricter rules. And that brings us to the second type, FIFO, which, as you probably know, stands for first in, first out. And this movie ticket lineup analogy, it is absolutely the perfect way to think about it. The order you get in line is the order you get served, period.
This table breaks it down perfectly. On one hand, you have the standard queue. Its main goal is massive, almost unlimited throughput. It guarantees that a message will be delivered at least once, but the ordering is what they call best effort, which is a fancy way of saying messages might arrive out of order. This is perfect for tons of tasks where the sequence doesn't matter. On the other hand, you've got the FIFO queue. This is for when the rules matter. ordering is strictly preserved and messages are processed exactly once, which prevents any duplicates. Think financial transactions or user signups, things where order and uniqueness are absolutely critical.
Okay, this all sounds great in theory, right? But where do people actually use this stuff? Let's look at some real-world situations where SQS is the perfect tool for the job.
I mean, SQS is the quiet workhorse behind countless systems. E-commerce sites use it to handle the insane flood of orders during Black Friday. Media companies use it to queue up video transcoding jobs. It's fantastic for processing huge streams of data from IoT sensors. Heck, even NASA uses it. And one of the most powerful patterns you'll see is the fan-out, where one message from another service, like SNS, gets delivered to a bunch of different SQS queues so multiple systems can all react to the same event. It's incredibly versatile.
Of course, SQS isn't the only game in town. There's a whole world of tools that do this kind of thing, what we call message brokers. So to wrap things up, let's just quickly see how SQS stacks up against some of the other big names you might hear about.
So when you look at other popular options, like RabbitMQ or Apache Kafka, they are incredibly powerful tools, no question. But they come with a hidden cost. You have to run them yourself. That means setting up servers, managing clusters, handling scaling. It's a lot of work. That's the operational overhead. SQS, because it's fully managed, just handles all of that. You get all that power and resilience without the headaches of managing the infrastructure. For getting started quickly and reliably, it's pretty hard to beat.
So we'll leave you with this question to chew on. As our applications get more and more complex, more distributed, could this simple act of putting a queue between your services, this act of decoupling, be the secret weapon you need to build truly robust, scalable, and resilient systems? It's definitely something to think about. Thanks for tuning in.